Hello, Math 1 students. This is Mrs. Gillahan again, and we are currently working in task 1.7, and this is problem number 9 from your RSG homework. We are looking at this one particularly because it does involve some partial, fraction, or decimal, depending on how you look at it, information. So let's get started working through this. It says Michelle likes chocolate, but it causes acne. She chooses to limit herself to 3 chocolate bars every 5 days. So she eats only part of a bar each day. And so what I did, and you know me, I am a huge fan of how the table can help us keep organized. So I started by setting up a table here. And of course, if we're going to be asked if it's arithmetic or geometric, we have to determine the growth process going on here. So I started a table, and we have days over here and bars over here, and I filled in what we know already. So on the 5th day, by the 5th day, by the time it rolls around, she will have eaten 3 bars. And likewise down here, when it gets to 10 days, she would have eaten a total of 6 bars. Now the question is, how much does she eat each day as we go through here? These gaps are very important, especially if we have to write functions for these. We have to know what f of n is. So we need to know how much she eats on the 1st day. We need to know the common difference or the common ratio. So let's actually get started with tackling how much she actually eats every day. So if she chooses to limit herself to 3 bars every 5 days, I kind of have a model here. And this is just, we've got 3 bars sitting here. And the way I was thinking about it is that, well, if she can eat 3 bars every 5 days, that means if she takes every bar and divides it into 5 pieces, she can eat one of the pieces of each of those bars every day. And this may be a little bit of a convoluted way of looking at it, but it really helps us see the fraction that is working at work here. So I'm going to start, and I'm going to label the portions of the candy bar that she could eat, for example, on day 1. So she's going to be able to eat, because she wants it to last for 5 days, she's going to eat a little part of it here, and she's going to eat a little part of this bar, and then she's going to eat a little part of this bar. Okay, so she has eaten a part of a bar each day, and she still has 4 days left, and she will now, on day 2, she'll be allowed to eat a little part of this bar, and then another little part of this bar, and then another little part of this bar. Okay, and she still has 3 days left, and you can see each bar has 3 sections left. So let's go over here, and on the 3rd day, she'll be allowed to eat a little bit of this bar, a little bit of this bar, and she'll be able to eat a little bit of this bar. Now on the 4th day, let's go and use this. She can use a little bit of this bar, eat a little bit of this bar, and eat a little bit of this bar. Okay, so we should see a pattern happening. So let's start at the beginning, go back to the very beginning, okay? She ate a little bit of this bar. She ate 1/5 of this bar on day 1. She ate 1/5 of this bar, on day 2, and she ate a little bit of this bar on day 3. So that's 1/5 and 1/5 and 1/5. So she actually has eaten 3/5 of a bar on day 1. Now we're going to plunk that in here and as just a fraction. Now if you so choose to use 3/5 as a decimal, that is fine, because we know that 3/5 equals 0.6. So you could easily use either one as your common difference or as your common ratio. It does not matter. It doesn't matter unless you are told to specifically stick with fractions or stick with decimals. Or if you're having a repeating decimal. With these, you should definitely stick with fractions. Okay? So she is basically, we're figuring out here that she is eating 3/5 of a bar each day. So on the 2nd day, she would eat another 3/5. So the total candy bars eaten at that point would be 6/5, or 1 1/5 bars. Okay? So by the time she gets to a 5th bar, now we could continue this pattern, but we really have everything that we need. We know that the first term is 3/5, and we know that every day she eats 3/5 of a bar. So this would definitely be an arithmetic sequence, and because it is an arithmetic sequence, we can see that it is adding the same quantity each day. We have a common difference in this situation. All right, so let's tackle our equations. We know that we're adding 3/5 each day, so like on day 2, she would have eaten 1 1/5 bars, or, oh boy, let's fix that, 1 1/5 bars, or she would have eaten 1.2 bars. We could add 0.6 plus 0.6, or however we want to show it, whether we're doing a decimal or a fraction. Okay, I chose to show my equations with fractions, so let's take a look at the recursive. Remember, for a recursive, you always have to give yourself the first term, so f of 1 equals 3/5, and we notice in our table that the first term is 3/5, and then we always have to give what exactly is happening in this situation. In this situation, f of n equals, we have to look to the previous term, and then we have to add 3/5 to that term. Alrighty, so if I was looking for the second term, I would have to go back to the first term, add 3/5, and that would give me the next term. And likewise, 1 1/5, I can add 3/5 to that, and I could figure out the third term. So let's plunk in the third term here just for good measure, and it would be 1 4/5, because I'm adding 3/5 to each term in order to get the next term. Okay, now the explicit function is very similar. There's only one of them, and remember, we use f of n to indicate that any term we're looking for, any possible term number, or any number of candy bars that she would eat on a given day. Let's say we're looking for day 18. We could use f of n, and instead of n, we would put 18. But the generalized explicit function here, f of 1, so we would plunk in our first term, which is 3/5 here, plus the common difference of 3/5. We established that we're adding 3/5 of a candy bar each day, times n minus 1. And that is our explicit function for problem number 9 in RSG 1.7.